Part E asks, what happens if you bring a positively charged piece of tape near a piece of paper? And we need to find out, and we also find out that the paper is attracted to the tape, which has a net positive charge. So we're trying to figure out which of the following statements do we know to be false. And so the first question is, the paper has a net positive charge. We know this can't be true because opposites attract and like charges repel. Therefore, the paper cannot have a positive net charge, or else they would have repelled and not attracted. So next two is that the paper has a net negative charge and that the paper is neutral. So we don't know if the paper is negative or neutral because we just see that an attraction is present. And we know that it just cannot be positive. The next part of the question is, the electric field of the tape causes the electron clouds that are bound to individual atoms in the paper to shift, creating an array of induced dipoles. We don't know if this could happen or not, based on just the attraction. And then the last part is the electric field of the tape causes the mobile electron C in the paper to shift. We know this is false because paper is an insulator and therefore does not have a mobile electron C. The last part of the question asks how to draw a scenario. So the scenario is that there's a solid plastic ball and it's brought near a rubber sheet with a positive charge uniformly distributed over one side. That's these positives. So it's asking how to draw the paper, the charge distribution on the plastic ball according to the book. So first we're going to draw the ball, and then we're going to decide if it's an insulator or conductor, because that's going to depend on whether the charges are on the inside or the outside of the ball. So we know it's an insulator because it's a plastic ball, and plastic's an insulator. Therefore, we're going to have these charges inside. Next thing we need to do is figure out which way the dipoles on the inside are going to be facing, or which way the molecules are going to rearrange themselves on the inside. So we know the positives over here, so it's going to pull it. The positives are going to push them over here. So we have negatives and positives, negative, positive, negative, positive, like this. It's kind of hard to see. Thanks for watching, and that's the question 2.